Hello YouTube, SentinalhMC here with episode 23 of my RotaryCraft tutorial series. This video we're rounding out the power transfer section of the handbook by talking about the shaft power bus controller and the shaft power bus. It's a very powerful, very useful, modular sort of a way to easily redirect power into multiple directions at various gear ratios and automatically split it up. It's really cool. We'll go through it. There's a lot to talk about with these things. It's quite powerful, so there's quite a lot of components anyway. So you need to make both of these recipes in order to use it. This doesn't work without this. So to create the shaft power bus controller, which is where the power gets input into, you need 4 steel ingots, 4 shaft bearings, and a circuit board, which gives you 1 bus controller. So it's actually not that expensive, because shaft bearings, they're not that expensive at all. So it's not a very expensive thing to make. So you probably want to, because it's quite good. Then you need to make the shaft power buses themselves, because the controller is what gets the power. It's what you put the power into, and then it feeds that power to the buses. And the buses are even cheaper because they don't require a circuit. They only require a belt, and you get 4 of them. So it's really nice. You get 4 of them for a recipe. So yeah, really good. So what this does, I'm going to come over here and we're going to use the hydrokinetic engine as our example. What it does is when you place the bus down, whichever side is facing, in line with where you're looking, that's where this hole is going to go, and that's the input. Excuse me, that's where you got to put the power. So I'm just going to place it right up against here. But it does require lubricant, which is perfectly fine. You can put the lubricant in any side, so you might want to put it in either the top or the bottom, because then you're not blocking any of these sides. I'm actually not sure if this will connect to one of those. Yeah, you can't do that. These sides with the circle and the lines, those are where the buses go. So lubricant in the top or probably the bottom, but I should probably verify that for you. Yep, lubricant can go in the bottom as well. So top or bottom, put the lubricant. So I'm just gonna tap into the lubricant we've already got over here. I can just pull up above the hydrokinetic engine. And so now we got lubricant in there. It holds 8,000 millibuckets. Doesn't use it that quickly. See, it's taken one every couple seconds, I think, which is perfectly fine. This grinder hasn't been running for a while because we've got so much lubricant in this tank. So now we've got the bus controller placed down. It says that it's receiving 16,384 newton meters at 32 radians per second, which is what we want. It gives you the wattage, and it tells you how many watts of power is being split to how many devices. Right now it says 1 device because it's basically just counting itself, but we don't have any devices, we don't have any buses placed down yet. If I go ahead and place a bus here, it still only says 1 device. That's because these buses, once you place them against the side, you right click on them and they've got this GUI in here, and it might look confusing, but it's actually really simple. It shows you the 3 sides that aren't connected to the bus. It's really smart like that. So you see over here now it's showing me that one's... So you never have to worry about remembering which side is connected to the bus, because that side is automatically removed from this GUI, which is awesome for clarity and ease of use. And so what you do in this interface is you place shaft units or gear units, and that is what allows the power to go out through a side. So the shaft power bus will ignore any sides that don't have a shaft unit or a gear, and it will evenly split the power that it's receiving between all of the sides that do have a shaft or a gear. So if I go ahead and place a shaft, but you do also have to watch yourself, because the shafts and the gears still follow their load limits. So if I go ahead and put a shaft unit on the red side, now you'll notice that nothing's happened yet. That's because there's actually no device on here for it to give the power to, which is, it's really nice because it lets you place shaft units that, and then it won't break or something until you put something down. But if I go ahead and place this dynamometer, it breaks. You heard that sound? Because the steel shaft unit obviously can't take 16,384 newton meters. Now there is a bit of an interesting interaction, because usually you couldn't put a steel gearbox up against that amount of power either, but because you're able to attach these shaft units and stuff without activating it first. If I put a 16:1 gear unit here, and by the way, this button here, this is for torque and speed. So if these don't do anything if you put a shaft in there, but if you put a gear unit in there, T is for torque, and this, it's not a W. I don't know what it's called, but I'm sure it's a Greek symbol that has some sort of a name. That's speed. And so I've got a 16:1 X gear unit in here set to speed. If I put a dynamometer here, it didn't break, which is really nice. So it appears that the shaft power bus sort of intercepts it, and because usually if I was to attach the 16:1 gearbox straight up against that, it would break, because the amount of power coming into the side is greater than the the torque is greater than what it can handle. But the shaft power bus seems to sort of remove that, and I don't know, that's probably intended behavior. So what it's currently doing, you can see, is that it's taking the power that we've got in, and all the power is coming out this side, because this is the only device attached, and it's automatically applying the 16:1 gear ratio in speed mode. I'm pretty sure if I hit this button it would break, but currently it's not. So if we point at the bus controller, it still says it's being split to one device. Now we can change that. If I go ahead and put like a shaft unit over in the yellow side and put oh, it broke. That's right, I can't do that. Because remember that the steel can't take 8,000 newton meters, because that's what it was going to try and give it. So if I put the bedrock shaft unit in here, which it'll work. So this is another great thing for using your shaft power buses with bedrock shafts. If you don't want to, it's an easy way to split power, and then you don't have to worry about it, and you don't use as many shafts as if you were going to do something else. But anyway, now as soon as I place the dynamometer down, the shaft powered bus controller automatically sends half the power into the yellow side, which halves the power that was going out the red side. And now the bus controller is telling us that the power is being split to two devices. Alright? So it just automatically split that power, and as far as I know right now, you can't tell it to only send like a third or a fourth of the power in a direction. You'll just have to like manipulate it, like, I don't know. I haven't used this all that much, but it's pretty simple when you get around to using the thing. So let's go ahead and use this for something. Let's use our bus controllers to power our grinder with our gear ratio. So we had a 16:1 gearbox here and a 4:1 gearbox here. We got our bus controller. Let's get rid of this dynamometer and place our bus down. So we need a 4:1 and a 16:1 ratio. Well, you already noticed how we're able to put our 16:1 gear unit right in here, even though it's steel and it would normally break. And now here's another thing about the bus controller, is that these buses, it can be chained. So you can chain the buses together. So if I go ahead and place a bus here, it's getting power from, ooh, okay, never mind. Alright, so you can chain the buses together, but you can't transform the power between them. So I was seeing if I could put a 16:1 gear unit here, put a bus down and next to it, and then the power going from this bus to this bus would be transformed, but it's not. This just disappears, this little bit here. So you can chain these buses together as much as you want, but you can't do anything in between them, basically. But it's still really useful, because if I were to go ahead and and put two dynamometers here, and then it doesn't really matter if I do that or not, and then put let me get some more bedrock shafts. Put a bedrock shaft here, put a bedrock shaft here, and we're getting power out. 174 kilowatts at 5461 newton meters seems a bit strange. Is it just me, or does that seem like an odd amount? Okay, so yeah, it is transporting the power without having a device over here. Sometimes it seems like you need to have a device, and other times it seems like you don't. But it is splitting it, so that's pretty cool. Okay, it looked like it was fluctuating for a second. So that's how these buses are functioning here. So now that I took that bus off, we got our gear unit back in, which was nice. Now I don't know of a way to get a higher ratio out of these buses, because you can only put gear units in here, but that's the way it goes. So now I could go ahead and put another gearbox down, like we had our. Now we've got our 16 to 1. We need our 4 to 1, but now we should be able to go ahead and use a steel 4 to 1. And I am going to place it like this so that it can get the lubricant in, and then swap it into speed mode, which is what we needed. And then I'll turn it over here. So now we've got it. And if I take another dynamometer, and I got rid of it. I always get rid of the device that I'm going to need next. Place our dynamometer down, and now... Wait, something's up. It's not the same ratio as before. Oh, do I have a... No, I don't. Do these things consume some of the power? I don't really know. It says it's being split to 3 devices, but it should only be actually split to 1 device, unless it's counting all the devices that are attached to it. This should actually be 128. Let's see. I don't like it when things don't work out the way I think they're going to work out on camera. It seems so simple. Let me get rid of this so I can write. Let's see. Being split to 3 devices, power per side is 174,000 watts. But it should only... Oh, I think... No, because it's getting 524,288. So it's getting the full power. Oh yeah, I'm an idiot, because we weren't ever running it with this much power before. We were running it with half the power. So yeah, I'm stupid. It's working perfectly fine. I'm just derping out. So if I put a shaft unit here and that won't work, I'm stupid again. Remember your load limits. But if I put a 2x gear unit here and swap it into speed mode, it should be able to work. Oh, there we go. So now we're back to where we were before. We're back to having our grinder running at, a pretty decent speed, about, the 12 seconds, 128 newton meters of torque at 2 kilorads, and we're getting our power out the other side. So essentially, these buses act as shaft junctions. But they allow you to easily add on. Whereas with and they automatically redistribute the power, whereas with shaft junctions you do have a bit more control over how much power goes in which direction, and you can totally use them in conjunction with these buses, but the buses do have to be connected to the controller or to another bus. So we've got that going on right now, and we got the rest of the power coming out this way, and we can do whatever we want with it. That's the shaft power buses. They're quite nice. That you can put any sort of gear unit you want in these things, and you could totally recombine the power that comes out of 2 sides using shaft junctions and bevel gears, and would that give you a different ratio? Yeah, it would. I think maybe. I'm not sure. No, it wouldn't. Recombine it. It might allow you to get more power out of one side than the other side. So if you have 262 kilowatt, or if this was split down again and you had it outputting to 2 sides and then recombined it, then technically that output would have twice as much power as one of the other outputs, because you've taken it from 2 sides. Does that make sense? I think it makes sense. But anyway, this is the shaft power bus controller. It's quite nice, quite useful for distributing your power intelligently. Really good to use if you've got an absolute ton of power coming out of like a single generator and you just want to split it down quite a couple of times, and you don't want to have a bunch of shaft junctions, because remember, each one of these buses can split the power 3 times, and the controller itself has 3 sides, so you can split the power 9 ways. Because you can only get these 3 sides. You can split the power 9 ways off of a single block, although it ends up being 3 blocks, and you really couldn't do it in the corners if you put these right next to each other. Actually, you could, because there's a cross. There is actually a cross shaft you could put there, but would be really useful to use these for a high power engine like the gas turbine, or a RotaryCraft reactor like the one I got over there. Even though I don't have a turbine on that yet, but that's a discussion for another day. Yeah, the bus controller, I don't know if there's all that much left to say. Just remember that you have to place the buses down. Remember that it'll automatically split and distribute the power when you put new shafts in. So remember that, because if you have something running, like if I have this grinder running and now I've got the power going out here, if I were to place another bus over here and put a shaft in it, all of a sudden I have cut the power going into my grinder by half, and now it doesn't run anymore. Or maybe not quite half. I've cut the power down and it's just not running, and I've cut the power over here. So be aware of that when you're using these buses, is that if you're gonna add another bus, power bus down here, you might want to put more power into it. Just it's all just use your math and calculate the amount of power you're going to be manipulating. But remember, these aren't very expensive, so you could totally just build another one and use it somewhere else. But that's the shaft power bus controller and the shaft power buses. Remember, you get 4 of these buses per recipe, so they're pretty cheap. So yeah, I hope that you know how to use these now. They can seem a little bit confusing at first, but they're actually really simple. Just place the bus next to the controller, and then just put whatever gear ratio you want, set it to torque or speed, or put a shaft in it. It's really quite nice, because again, you can use this as a shaft junction. It's basically a shaft junction bevel gear combo, as well as automatically splitting the power. So quite powerful, but you might have to play around with it a bit to get the power distributions that you want. If you're putting a bunch of power in it and you want to get it to flow just right into whatever machines that you want, but play around with it, get it going how you like it. But the bus controller is quite useful. I'm probably going to start using these quite a bit, because they're a lot simpler than they seem. So I hope you've enjoyed this episode. We have now covered everything in the power transfer section of the book. I'm pretty sure. No, yeah, that's not nothing else here. Yeah, we've covered everything from power transfer. So the next thing that we could do is I can either go down through the list of production machines, talk about all of them that we haven't talked about yet. We have talked about all of these ones. We could, and I could just go straight down, and this section includes all the mod interaction machines. So I'll either do that, or you can suggest what section of this handbook you want to talk about next, if you really have one that you really want to talk about. Like, I know some people have wanted to see the defensive and offensive machines. So if you want to take a look, just let me know. And seriously, do it. Don't. I'd like it if everybody who comments can include this in their comment, because I have to know what you want to see next. Otherwise, we're just going to go down the list, because that's the easiest way to do it, unless you want to see something specific, because this is a quite involved section. So once we start talking about these weapons, I'm probably going to have to devote entire episodes to one of them, but I'll have to figure that out. So let me know what section of the book you want covered next, and we'll just go through it. Because I do eventually want to cover everything in the handbook, and if I keep skipping around like I've been doing, I might forget something. So let me know what you want to see next. for the people who are wondering, and they ask quite often if I'm planning on doing a tutorial series for ReactorCraft, and the answer is yes, and then also for ElectroCraft, at least for what's out right now, but that's not going to be for a long time, not until I finish RotaryCraft, because I want to finish one tutorial series before I start on another one. And so, yeah, let me know what you want to see next. I hope you're enjoying the series. I'm SentinalH, and I'm signing out.